Welcome to this session. Hopefully you guys can hear me okay. My name is Nico Kabar. I'm a solution architect at Tigera, and today we are going to talk about how Calico Enterprise enables your Kubernetes multi-tenancy. As just a reminder, if this is your first time joining one of our webinars, it is a recorded webinar, so you can always go back and rewatch it. It will be available after the session. We'll post it to our YouTube channel as well as the events page under tigera.io. So let's keep going. Just a bit about myself real quick. I've been with Tigera for about a year, and prior to that was with Docker and Cisco. So pretty much with spent the last 10 years working around networking and containers and Kubernetes and cloud. So this is kind of my passion is around those areas. And for today's discussion, we're going to be doing a quick overview of Calico, so to help you get familiar with both Calico and Calico Enterprise if you're not familiar with either of those solutions. We'll kind of dig into Kubernetes multi-tenancy overview and talk about the key primitives for multi-tenancy, especially in the context of Kubernetes, and showcase some of the Calico Enterprise capabilities that can enable that and are aligned with the Kubernetes multi-tenancy and best practices around those. And of course, we'll finally talk about specifically one area that is really critical around multi-tenancy, which is around compliance. And see how you can use Calico Enterprise capabilities to achieve that in a multi-tenant environment. Feel free at any given time to type down or write down your questions in the Q&A section. I'll spend the last 10-15 minutes trying to answer those. So if you have any questions, feel free to add those in there, and happy to answer them towards the end of the call. With that being said, let's get started. So what is Project Calico? If you're not familiar with Project Calico, it is a community-driven open source project that was started around the same time as Kubernetes. It is a solution for Kubernetes networking and network security that aims to make it extremely simple to connect your pods and secure them. And actually, we go beyond that to provide similar functionalities around security for virtual machines and host-based workloads in a cloud-native way. So why many users out there are using Calico? Simple, secure, and scalable solution for its providing a very fast or blazing speed when it comes to performance for pod networking. This is mainly due to the native Linux data plane that Calico uses, and also architecturally providing a simple flat layer 3 network with or without encapsulation is key for achieving great basically levels of speed and performance for your pod networking. It is massively scalable, mainly due to the fact that it's built on the routing protocol of the internet, BGP. So really the scale of your Kubernetes environment is limited by Kubernetes scale itself, so the number of pods per node or number of nodes or whatnot, and other factors, of course. So networking should not be your kind of limiting factor when it comes to scale there. In terms of industry adoption, all major clouds out there, AWS, Google, Azure, IBM, have standardized around using Calico for network policies. It's the default engine for network policies. So if you use AKS, EKS, GKE, that is the default option, as well as for many hybrid solutions like Docker Enterprise from Mirantis, Rancher, as well as Red Hat OpenShift. There's been Calico as a certified option for all those, and some of them actually embedded as the default there. We've also seen other distros like Nutanix Carbon and others have used Calico, and Platform 9 have used Calico out of the box So that's an affirmation of the quality and performance that Calico provides. Of course, there's real-world production hardened. It's been used by plenty of enterprises today. We're aware of more than 200,000 known clusters out there that are using Calico, powering over 1 million nodes today in the wild. So Tigera, just an overview of Tigera itself. Tigera is a company behind Calico. We invented and maintained Project Calico. Call it some of also the Istio security working group as well, and even helped drive some of the spec for the Kubernetes CNI spec from the early days and even the newer version of that. Now, in terms of Calico Enterprise, which is the enterprise version that builds upon the power of open source and provides an extensive set of features and functionalities to address enterprise use cases. You can see here some of our key customers, large customers, Fortune 100, Fortune 500 customers are using Calico Enterprise today to secure their workload across different verticals. So that's a quick overview for Calico and Calico Enterprise. Finally, just as a reminder, Calico itself and Calico Enterprise pretty much run anywhere Kubernetes run and beyond that. So whether you're using a managed Kubernetes service or a self-managed or on-prem hybrid solution, those are all valid options for where you can run Calico and Calico Enterprise. And also beyond that, we provide multi-cluster management. So if you have hybrid clusters running across different Kubernetes clusters, or even within the same environment, there is a federated security model that we provide in multi-cluster management. So with that, just a quick kind of overview to make sure that you guys are aware of what Calico is and what Calico Enterprise is as well. So let's kind of switch gears and talk more around multi-tenancy and why you should care and how Calico can help you. But before we begin that, let's talk more around just the core concept of multi-tenancy when it comes to Kubernetes. I'd like to use a scenario here when to kind of demonstrate or go through this. So let's say you're part of a platform team responsible for designing a Kubernetes platform internally for your various teams, for your different applications. So you as a platform owner, after going through research and R&D and getting all the requirements and so forth, fast forward to the point where actually you can create a cluster for that group or tenant to deploy their application, provide the infrastructure layer, the compute layer, storage, network layer, and the control plane of Kubernetes, deploy that. The Kubernetes control plane components themselves, provision the worker nodes, the compute nodes based on the tenant requirements, use managed or unmanaged Kubernetes solutions, regardless of on-prem or on the cloud, and start managing the environment for and kind of providing certain SLAs for that team. If you're taking that model, or this is a very common pattern, there's some type of SLA that either the platform team or SLA teams that are providing this service internally, this Kubernetes service, have to kind of deal with those kind of steps and ensure that the application owners get that level of SLAs delivered to them. And application teams then can start working with those with this service, with this Kubernetes service that you have provided to them, and they start migrating their applications. So let's say this is you've done this successfully, and another organization or team has heard about all the great things that you've done and all the great benefits of using Kubernetes to scale their applications and to deploy their application faster, and all the kind of the benefits of Kubernetes. So they request kind of the same, engage with you and your team to request the same level of Kubernetes solution provided to them, because you went all through that and you made sure that it is provided as a service internally, went through all the pains and challenges of designing and implementing it. So they want to make sure that they get similar solution from you. So you go through the same process, providing similar environment, set some of the SLAs and start managing the environment for them, and provide the application team some method to deploy their applications and migrate them to Kubernetes. So this is great, but then, fast forward, you have 10 more organizations kind of hearing all the great stuff that you've been doing, and you guys can see here the trend is this is becoming unmanageable. Maybe with 1 or 2 clusters, or a handful of clusters, it is manageable. But when you go beyond that, then there's an even could be a linear staffing and kind of manpower necessary to go and manage and provide the same set of SLAs for different teams as you scale the number of Kubernetes platforms that you're providing. So you kind of start questioning the approach you're taking around how you provide this platform to the various application teams. So this is where, what kind of brings us to the main topic here, which is on multi-tenancy, which is ensuring that you provide the level of service, the Kubernetes service, to your application teams, but without the additional cost associated and overhead, both from a operational cost itself and operational kind of man-hour and maintenance required per cluster. So this is where you kind of pivot to taking a more multi-tenant approach. So let's kind of define what is multi-tenancy, and especially in the construct of Kubernetes, is kind of providing Kubernetes as a service, and using the same environment, or the same Kubernetes cluster, but having it be shared by various teams. Now we're going to talk about various types of multi-tenancy. The first time is one that I just described, is basically providing Kubernetes itself as a service. It is, you create the cluster, multiple clusters that are, shared by different groups or tenants. They share the same cluster resources, from compute, network, storage, and so forth. And the applications reside side by side, utilizing the same set of infrastructure resources. So this is like providing a platform level isolation. The tenants themselves are internal tenants, and they are Kubernetes users, in the sense that they have access to the Kubernetes API, and they can deploy directly or through a CI system, or whichever method they pick to choose. They have full access to the Kubernetes API. And the tenants, as I said, are internal to the organizations. Now, from a compliance perspective, when you're talking about multi-tenancy, given this is more of an internal service, a platform service that you're providing internally, the compliance requirements are dependent and may vary depending on your organizational requirements that are well established for this sort of multi-tenant environment. So there's no standardization because it's really internal. Now, if we switch and talk more on delivering software as a service using Kubernetes, this is the contract is different. This is the second type of multi-tenancy, where you're running an instance of a service per external user or tenant. Especially if you're providing any type of SaaS service, you're using Kubernetes just as a mechanism to deploy the application, but you're running an instance, or this could be without digging deeper into what type of application, but this is highly dependent on the type of service that you're providing. Sometimes tenancy here means a different database instance. Sometimes it's a different authentication instance. Sometimes it's a different version. If it's a managed service, it could be also the application itself that you're providing. So there's a lot of options here, but the idea is that the tenants here are external to the cluster. They're opaque to Kubernetes. They have no awareness of this. Their application is running even Kubernetes, and therefore they do not have access to Kubernetes API. The users here are external to even your environment or to your company or organization. So this is providing application layer isolation. It is not mutually exclusive from multi-tenancy type 1, so you can do both. And for SaaS specifically, for providing SaaS service, there's some, definitely many compliance requirements, but SOC 2 definitely stands out if you're hosting any data, customer data, client data. And if you're in the healthcare industry, if you're in the financial industries, there's insurance and so forth. There's a different set of regulatory requirements to also meet in addition to providing service. So there's those to kind of consider when you're designing your multi-tenant environment using Kubernetes. So this is a second type, I would say, for multi-tenancy. Again, it's not mutually exclusive of the first type. So why use multi-tenancy for either or both types that I mentioned? And there could be more types. Well, those are the ones that we're seeing kind of the value and the benefits of. I would say there are three key benefits of using any approach or any type of multi-tenancy. One is to reduce cost by utilizing the same cluster from both control plane, compute, and data plane, or compute resources, storage resources, networking resources. So that's kind of the first benefit. The second is increased resource utilization, of course, because you're going to be driving more applications on the same set of workloads, or on the same set of compute resources. You can scale horizontally, and you can drive true, increased level of utilization for those resources, all while reducing operational overhead by reducing the time and manpower to operate those clusters, to manage them, to upgrade them, to secure them. So not only from a ongoing cost perspective, like financial aspect, there's also tremendous benefits from a reduction in operational overhead by taking this approach. So if we take a look at key Kubernetes-specific multi-tenancy primitives, of course, if you just launch a cluster today and it's not just going to automatically be multi-tenant ready, there's a lot of things to consider when it comes to true multi-tenancy around Kubernetes. Let's kind of walk you through them. Of course, the first construct in Kubernetes that makes it easy to implement multi-tenancies is just a construct of namespaces. Of course, there's the logical mechanism to organize objects and then apply certain restrictions or permissions based on those objects. So namespace is a key thing to use when you are creating those tenants in your Kubernetes cluster. The second is around network policies to make sure that from a networking perspective, you have complete isolation between the various namespaces. We'll talk more about that as well today. Third, resource quotas. So if you just leave Kubernetes as is, when you start onboarding different teams and their applications into the environment, they can, if one application ends up kind of hogging the resources, CPU resources or memory usage, that could be impacting other applications. So it's really important to provide and implement resource quotas to ensure that one tenant does not, hog resources for other tenants, and there's some, you're boxing those quotas to ensure that. Fourth, of course, creating the tenants and how you organize the grouping, both from a user access and RBAC to the various objects that they have access to. So that's kind of how you align the tenants and the groups, how you create them from an authentication perspective, from an authorization perspective, and how you provide the granular roles, the RBAC roles and role bindings associated with them to ensure that only the select teams or groups or users have the right set of authentication and authorization to access their respective objects and subjects. Finally, of course, this could be a hard multi-tenancy requirements. In that case, there are ways within Kubernetes you can have of course, create a separate Kubernetes clusters, kind of defeats the purpose, but also another mechanism to dedicate certain nodes, compute nodes, worker nodes for specific namespaces, specific tenants, and therefore the benefits of the first kind of 5 on the list here is still there. You have a single control plane. You're still defining quotas, but where the application runs is always isolated from other applications, and that can be really useful for certain types of applications where there needs to be a dedicated compute nodes for them. So if we take a look at those at least 6 primitives that are really critical for when you define and when you design your Kubernetes clusters, you need to keep them in mind, and you need to kind of go through each one to ensure that you're providing the right set of design considerations and to meet those requirements through those key primitives. Now with Calico, and now we're going to switch a bit more to Calico and Calico Enterprise to see how and which one of these can it help you with. So let's kind of take a look. So now that we understood the Kubernetes multi-tenancy primitives, let's take a look at 7 ways Calico Enterprise can enable multi-tenancy for you. Because as I said, there's multi-tenancy is not going to happen automatically for you. And a lot of the users or customers I work with, even when they use managed Kubernetes clusters, they end up trying to avoid dealing with multi-tenancy by just creating additional clusters. And although it can be a simple solution at first, but soon you realize that you realize the additional costs associated with that, and you're missing on the benefits of really using Kubernetes, while defining certain using those multi-tenancy primitives to actually get to a multi-tenant environment without the cost and overhead of managing, and going through this kind of clustered sprawl that you might get into if you take the different approach when it comes to multi-tenancy. So the first way that Calico Enterprise can help you with multi-tenant multi-tenancy design is by using network policies for tenant network isolation, right? This is a key primitive that we discussed. This is the second primitive that we discussed in Kubernetes multi-tenancy. You can achieve network isolation per tenant by applying network policies on the pod, on the namespace, or on the service account level for each one of your tenants. You can automate this process. You can make it seamless. You can make sure that you have deny and log traffic across tenant namespaces, and you have a track record of any attempt to cross the tenant's namespace. One thing to remind you of with Calico, there's a concept of global network policies, and it's really critical because that's not a construct that's available in Kubernetes network policies. So with Calico, you can actually have global network policies that apply to all the namespaces or select namespaces. That way, you can get to a point where you have those high-level policies enforced regardless of the number of tenants or number of namespaces created in the cluster. Finally, you can also apply egress access controls via DNS policies so that they can apply to the pods and services running within each of the tenants to either restrict or allow access to certain domain names. And this is important to remember because typically, especially in multi-tenant environments, if you have two different tenants and they have different egress access requirements, so let's say tenant 1 needs to access the prod database cluster and tenant B wants to access a dev database cluster. And if you just use, since they both can be running the pods from those two tenants can be residing on the same compute node, you can't as you're trying to access external services, you don't want to open up all the traffic coming from that node to access the prod cluster that's sitting outside of Kubernetes. So by using DNS policies, Calico can take care of only allowing those pods and the tenant that's allowed to talk to the prod database cluster to be able to do that, even though there's a pod sitting right next to it that is not allowed to do so. So that's important to remember here. So network policy is at the core of achieving tenant network isolation. Second, when it comes to tiered security policies, so the cool thing about just Kubernetes network policies is that you can use them. They're just another YAML artifact that you can have residing or kind of managing it through like any other asset in or application asset in your source control. But the problem with it is it's a flat kind of approach where you can either deploy in a policy or not, depending on your RBAC permissions, and there's no mechanism for security teams or other platform teams, for example, to define more generic, more cluster-wide policies that take precedence when it comes to enforcing traffic. So let's say if you have certain, the security team has certain requirements, and those are translated by certain network policies that need to be enforced across cluster, and only if those policies get passed, then the application network policies for that tenant kick in. So there's no way to do that, and Calico Enterprise can help you define those tiers to be able to do that. And the enforcement happens. You have tiers, and there's UI around that as well, where the policies are evaluated left to right, top to bottom. So there's a level of hierarchy there to ensure that certain teams can provide a consistent and uniform cluster-wide policies before each of the tenants can define their own policies. Third, compliance is really critical. Compliance, reporting and dashboarding. If you are in a regulated industry, if you are, of course, you're providing either type 1 or type 2 multi-tenancy, you need to make sure that you have a summary of useful data when it comes to being compliance, how many namespaces are protected, if there's any violation to the policies. This could be global, and this could be also app specific. So you can generate those compliance reports on an ongoing basis and have a track record of your cluster environment meeting the requirements that you set forth. And it's especially critical in multi-tenancy. That way you can ensure that any breach to specific tenant, if that happens, the enforcement that you're doing is consistent across all the tenants, and you have a track record to show that. Next, audit logs, ensuring that, especially in a multi-tenant environment, you want to make sure that you have a trail record of all the interaction that happened with the systems. You have a version history. You can compare version. Here we're talking about the network policies that were created, who did what when, and what happened really. So you have a good track record of all the interactions with the system, whether it is using kubectl or the UI. Everything is tracked and can be audited. So you can make sure that you have that. It's typically a very hard requirement for any multi-tenant environment. Fifth, in-depth threat detection, protection, and mitigation. This is something that we provide out of the box. Especially in multi-tenant environment, you want to make sure that if there's a breach going on, if there's any intrusion that is ongoing in a specific tenant, there's a easy way to detect it, stop it, and isolate it from other tenants. And by using Calico Enterprise, we have an kind of anomaly detection on IDS system that is built from the ground up for Kubernetes that uses machine learning to detect known attacks and stop them where they are. So it is very critical, especially in multi-tenant environment. The last thing you want to do is create a multi-tenant environment where you're reaping the cost of lower overhead and lower OpEx, but then you're exposing more applications because you're not putting the right guardrails, and you're basically opening it up for certain malicious activities to impact multiple tenants. Of course, from an alerting perspective, any activity that is detected, any policy that is dropping traffic, or there's any issues with it, or it is blocking certain traffic, you can alert based on that. Whether it is related to, as I said, network activity, policy activity, IDS related DNS activity, all these are valid alerting options. That way, you have a quick way to detect and mitigate issues, as I said, in a quick manner. And we provide, of course, the templates for available alerts out of the box for you, so you don't have to worry about that. And you can integrate it with any alerting system, with Slack or PagerDuty, or even integrated into CM if you're using one today. Finally, RBAC is really critical when it comes to any multi-tenant environment, to secure it. We in Calico Enterprise, we provide an easy-to-use flow logs and a flow log visualizer to fully understand what's going on in your environment. So as an application owner or part of the tenant, if there is an issue with the application, if I want to understand the true reach of each of the services and how they interact with each other, or other namespaces, or with other services internal to the cluster or external, this tool can truly help with that. But not only that, we provide an RBAC-Protected advanced logging, so you can provide Calico Enterprise access to each of the tenants, and they're protected by RBAC, so they can only see what their namespace or namespaces allows them to, and only that. So that's really critical for kind of this visibility and troubleshooting tool that we provide out of the box for those tenants. So as a summary, there is to meet kind of requirements for tenant isolation, you want to make sure that there's true tenant isolation from a networking perspective, using network policies, and different egress access controls, ingress access controls to define from a network data plane perspective. You should have the right set of compliance tooling, and auditing and alerting, and have a proof and track record of that using the compliance reports, as I mentioned, as a proof of enforcement for those various requirements. So this is a quick summary of how those 7 key things and beyond in Calico Enterprise can help you with tenant isolation. Let's switch gears and talk a bit more on SOC-2 compliance, because I think it's very critical to talk about that, as I'm personally dealing with a bunch of customers who are either launching new SaaS products, SaaS services, or migrating their monolithic applications from on-prem to the cloud, and they're providing some type of SaaS service around them. So there's, with that comes a responsibility around, especially if you're using both types of multi-tenancy, to really focus on what are the key requirements of SOC-2 and how Calico can help you achieve them. So if you're not too familiar with SOC-2, it's a set of criteria developed by the American Institute of CPAs to offer kind of guidance and certifications for companies that handle sensitive customer data. So, personal data, social security, for if you're talking B2C, or any sensitive data for B2B around the environment for your clients or customers. Anything like if you're offering a SaaS, PaaS, IaaS product that has any customer data, pretty much needs those SOC-2 requirements to be met. It is based on 5 TSCs, trust services criteria, broken into 9 common criteria. So, the trust services criteria are security, availability, processing integrity, confidentiality, privacy. And there's 9 common criteria around the control environment. You can see them on the right-hand side. But specifically, the 6th, 7th, and 8th common criteria around logical and physical access controls, system operations, and change management are really critical to, especially from what Calico can provide, because those are the areas where, especially if you're moving from traditional VM-based environments to Kubernetes-based environments, container-based environments, you can't just apply the same set of isolation, logical and physical access controls. As we talked about before, if you have multiple tenants residing in the same set of compute nodes, that's not a logical isolation. Pods are literally sitting right next to each other. So there needs to be a different approach to meet SOC 2 requirements. So let's take a look at how exactly we do that. So if we break down the SOC 2 requirements, defining the requirement in section 6, 7, and 8 on how to implement logical access security measures, how to monitor and detect configuration changes, how to monitor system and components for anomalies, and how to properly do change management, authorization, tracking, and approving changes to the system, and how this is met by the Pagera guidance from Calico Enterprise perspective. So Calico Enterprise can help with organizing all SOC 2 endpoints in one or more namespaces. So you can do that. Or if you have multiple tenants, you can apply using the tiered approach, apply certain policies that would ensure that you have that logical separation. So creating global network policies that as you onboard a new tenant, automatically secure that tenant, secure the namespace, ensure that it's not interacting with other namespaces. It's only interacting with whatever it needs to be interacting with, both in the ingress and egress direction. That is something that Calico Enterprise can help you with. Running on kind of online or ongoing inventory of all the protected endpoints, making sure that they are truly there's a policy enforcing them. Just answering your question, answering just simple questions like, are all my pods protected? Are they all secure? Which ones are not? Right? Easily be able to answer those quick questions can help you meet those requirements. From a monitoring perspective, we didn't talk a lot about the advanced flow logs, but Calico Enterprise has an extensive set of advanced flow logs that help with capturing, and storing and showcasing all traffic flow logs going between east-west traffic, between the cluster, between different tenants, as well as external to the cluster. So ensuring that you can monitor those flow logs, analyze them, have a track record of going back and understand what happened at certain times, and have the Kubernetes context for that flow log. Which namespace was it talking to? Which other namespace? Which IP? Which pod? What are the labels associated with it? Those are all critical things to make sure that you have all that is needed for this requirement. And of course, from a change management, we talked about audit logs, as well as the audit timeline to ensure that you always have that track record of who did what when and all the change management associated with that. So to summarize, we have spoken around what we initially defined what is multi-tenancy. We walked you through a scenario. We talked about the types of multi-tenancy, especially in the context of Kubernetes. Talked about some of the key primitives that enable you to do multi-tenancy in Kubernetes, and walked you through 7 ways that Calico Enterprise can help you get there. So this is kind of good thing for you to remember, especially around the 3 key areas in SOC 2, where Calico Enterprise can truly address those requirements and make sure that you are secure and ready to have a true multi-tenant environment. So with that, I would like to wrap up. But before I do, those are similar to this event. We actually have on host plenty of free learning events twice a week. So you can see of the upcoming events, and you can register for them in the link here, Pagera.io/events. We also send you, if you're part of the mailing list, we send frequent updates to those. So feel free to kind of register to those. They're free, and we cover a whole lot of topics there that can be beneficial for you. Finally, I did talk about Calico Enterprise. If you're not familiar with it, it's a great way to get familiar with it is to go through the trial. So if you go to tiger.io/trial, we actually provision a Kubernetes cluster for you on different platforms you can choose, and give you kind of a lab-oriented walkthrough of Calico Enterprise. So you can, to your own time, can go on and discover what Calico Enterprise can do for you and your organization, and without really having to set up anything yourself. So feel free to go to Tiger.io trial to sign up for that trial experience, hosted experience. With that, thank you again for the time today.